Hi, in this lesson, I want us to try and apply what we learned last time about faults. You can see in this photograph, uh, the rocks here in this cliff have been faulted. If we follow, for example, the light coloured bed that the student's sitting on, uh, along the cliff we can see that bed stops. It's been displaced. We can't actually see it anymore. We need to learn how to put into effect some of the terminology we learnt last time, and from that, be able to interpret the type of fault, because there are different types of fault depending on the type of stress that applies to a rock. So, we're working on page 7 of our booklets. Let's go. Okay, there are 3 or maybe 4 types of faults that we need to be familiar with. The first is called a normal fault. In a normal fault, we have crustal tension. So rocks here are being pulled apart. The effect of this is that the hanging wall of the fault is the down throw side of the fault. That's how we recognize this particular type of fault. There are other consequences of this. This block of rock, for example, gets a little bit longer. Okay, we have crustal extension. There's a vertical movement of the beds, and it creates a type of fault we call a normal fault. As I say, the key way to recognize this is that the hanging wall is down thrown. Another way of looking at it is that the fault plane dips towards the down throw side. So that's one type of fault that we'll find, like I say, in an area of crustal tension. If though we have crustal compression, where we see compressive forces pushing rocks together so that they break, we see this type of fault. Now, in this type of fault, the hanging wall has been upthrown. The footwall here is the downthrow side of the fault. Another way of looking at this is that the fault plane here dips towards the upthrow side of the fault. Again, we've got a vertical movement, what we call a dip slip movement. And this type of fault is a reverse fault. And also, the consequence of this is the crust here is shortened. So we can already start to see how the type of plate boundary, and with it the stress, would affect the type of faults that we can find. Now, the last type of fault we need to understand are what we call strike-slip faults. Now, strike-slip faults have no vertical movement, they just have horizontal movement. And this movement can be described as being left lateral or right lateral. The way to work out which is which is to actually model the movement with your hands. If you put your hands on, if you like, where the fault blocks would be, and move your hands as the blocks have been displaced, the hand closest to you is the one that describes the movement. So if the movement's like this, it's left lateral. If it's like this, it's right lateral. And it doesn't matter which way you're looking at the fault in terms of which type of movement it is. It's the same. Okay. Having explained that, let's see if we can put it into practice. Question B on page 7 gives you 3 simplified fault block models. This one's our first. I've asked you for each of these to colour in bed 2 like I've done here. That helps you pick out a sort of key, what we call marker bed, so you can see how the displacement has worked. So this is our first model, which is a dip slip fault. This is our second, also a dip slip fault. For each of these, I'd like you to label these diagrams up with the hanging wall, the foot wall, which side is the up throw, which side is the down throw, and what sort of stress is making these faults. Can we name them as well? What type of fault is it? And then can we describe how you actually identified these? What are the key features that lead to your identification? The third type of fault is this. This is a strike slip fault. Label this diagram up to show the movement. What type of movement is it? Is it left lateral? Is it right lateral? Okay. And then describe how you actually recognize that. How did you actually tell what type of fault you're looking at here? Okay. Time to press pause and have a go at those activities. Off you go. Okay then. Let's see what you've come up with. This is our first model of a dip slip fault. Let me label this up for you. So we've got our hanging wall and our foot wall labelled up. And then we have the up throw and down throw sides of this fault shown. This particular fault is a result of crustal tension. So if we look at this evidence, we've got crustal tension making this block longer, extending the crust here. Crucially, the hanging wall is the down throw side of this fault. So therefore, this fault is a normal fault. For our second model, again, we can put some labels on. So we've got our hanging wall and our foot wall. Our up throw and our down throw side. And this time the stress is compressional. Here we can see compressional stress has shortened the crust here. The hanging wall in this fault is actually the up throw side of the fault. The fault plane is dipping towards that up throw side. So this fault must be a reverse fault. The final of our models then, we already know is a strike slip fault. Here the terms up throw, down throw, hanging wall, foot wall don't apply because we don't have any vertical movement. What we see here is horizontal movement. This horizontal movement is shown because we have vertical structures here that have been moved, they've been displaced. If we have vertical structures that only get moved vertically, there's no displacement seen. This is a result of shear stress, this stress that slides past each other. And this is a strike slip fault. This particular one is a left lateral strike slip fault. because that left-hand side has moved towards you viewing it. So it's a left lateral movement. Okay. Let's go back to this first photograph we looked at. We can identify the fault planes here, or the fault plane. Sorry, there's only the one, which is along here where the rocks have actually been broken and displaced. We can also identify the movement. On the left-hand side there, the hanging wall has been down thrown. We can see the two lighter coloured beds at the bottom of that cliff, in the cliff behind the student. So we know that the down throw side of that fault is there above the fault. So the hanging wall here has been down thrown. The dip of the fault plane is towards that down throw side. And the rocks here would have shown some crustal extension. So this type of fault, or this fault that we see, is a normal fault. So, as we watch the sunset over the cliffs of Moher in Ireland, what I'd like you to do next is to look at the fault photographs that we can see on pages 8 and 9 of your booklets. What I'd like you to do is the same as I've just done for that photograph of the fault in the cliff. To highlight where the fault plane is, to mark on movement arrows to show the displacement of that fault, to label up the down throw side, and then to identify what type of fault is shown in each of those photos. It'd be good as well if you could use a different colour to show the stress then that's created the fault or even faults. There are photographs there with several of these on those photographs. We'll talk about the answers in the next lesson. I'll see you then.